Alright, so welcome to the next experiment. We're actually having a C on this one. So there's an A, B, and a C. So there is one flaw that we need to solve about this circuit. And that's most of the time that's kind of like that. It's like you get the circuit going and you can improve upon it in some way. How can we improve upon this circuit? Well, I'll show you. So if I turn this all the way, it gets super bright and super hot. Okay? So obviously we want it to dim down. We want to be able to go like that and then dim it all the way off, or go to where it's safe. But right now we can go clear into not safe for this LED. So the circuit isn't complete. Circuit needs something. Alright, so it didn't matter if we went with the resistor on the positive or the resistor on the negative. It didn't really matter, right? So this time I'm going to show you that it's okay to have both. And that would protect the circuit. Alright, so we're going to redesign the circuit so that it has a safety resistor in it. Stoic Cyclops. Boom. Alright, we're going to have our variable resistor, just like last time. It's going to get attached to the negative wire, just like last time. And now this time, we're going to have a second resistor. Okay, and the second resistor is going to be hooked up to the negative of the LED. It's going to look like this. Boom, 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 boom. Boom. And then it's going to go straight into an LED. Oops. Yeah, these are light beams coming off. I just sucked at drawing them this time. Alright, and then we're going to go right up into our leg of our resistor. So what did we need this one to be? Well, we went all the way down to 27 ohms on one of these experiments, and it didn't blow out this LED. In fact, I can go all the way down to 0. It just gets slightly warm. So I'm going to say, and one of the ones was 100. So I'm going to say 120. Yeah, 120. So I'm going to say 100. So between 27 and 130, we'll go to 100 ohms. And that'll be our safety cap for this resistor. And I know I have a 100 ohm somewhere floating over here. Alright, again, just for educational purposes, oops, I'll just put some of these signs in here for you. Remember that this is plus, negative, yeah. Alright, should we just start over? I'm going to not pull the... So this time, it doesn't really matter if we turn it clockwise, counterclockwise, it doesn't matter, right? Because we know that we have a backup here. So that's what's nice about this circuit. Alright, I do have to find my 100 ohm resistor. Should make my kids do this. Whoa, nailed it in the first one. Whoa, that's rare. Okay. Okay, got my 100 ohms. Got my green LED. Okay. And it doesn't matter what side this red one is or what side the black one goes anymore. It doesn't matter. That's all irrelevant just because of one resistor. Okay, so we got our 3, one hooked positive, one hooked negative. Okay, it looks like, so first off, this resistor is hooking up to my negative. You can see it hooked up to my power supply, it's hooked up to the negative, so I can run that right out of my rail. Boom. So you can see that what I did. Okay, and it looks like it's attaching to the negative side of my LED. So I can just run that into the next area. And then I can attach my power. And then I should be able to just crank this around. And there it is. So it does get bright, but it's protected. And it goes all the way down. And you see how like nice it is too. It's a lot nicer. Why? Because it has a negative. It has a way of going all the way to 0 a lot faster and a lot smoother. So you have a lot of control here. There's not so many bumps or dead spots in my potentiometer. Alright, so this is the preferred way. Kind of left that out just to show you that flaw, and that way we can like work on something together. So I hope that helps. And now we are done with the potentiometer for right now, but we will be using it a lot in our other experiments. So I hope you enjoyed.